Hey guys, and welcome to this lesson all about these things called complex rational expressions. And first things first, what is a complex rational expression? Well, a complex rational expression is just more or less when we have fractions within fractions. So they're going to be these rational expressions that have polynomials all over the place, but it's whenever we have fractions within fractions, which can be really scary and seemingly overwhelming, but we got a couple of strategies that I think are going to really help us simplify these, and I'd like to, per usual, start with kind of easier numeric fractions and then use those skills and apply them with these rational expressions. And so the first skill that I like to use, or the first method, is to, for instance, in this complex fraction, 3/4 over 5/6 is to treat it like division, because it is division, right? A fraction implies division. This just means 3/4 divided by 5/6. And we know how to divide fractions. In this case, to evaluate this expression or simplify it, we would take 3/4, and instead of dividing by 5/6, we would multiply by its reciprocal, 6/5. And now we're dealing with a fraction multiplication problem. This is no problem at all. This is 18 over 20 or 9 over 10. So I guess if I were to dub this method with a name, I'd call it maybe the multiply by the reciprocal strategy, or regard it as division strategy. All right, so let's talk about this now with regard to a rational expression. So here it's no difference. We've got one fraction being divided by another fraction. And so we're just going to treat it like a regular division problem. We're going to multiply by the reciprocal instead. Of course, the first thing I would suggest doing is going ahead and factoring everything. So I think our little numerator is x plus 1 times x minus 1, and our top little denominator would be 4 times the quantity of x plus 2. And by the way, that's kind of the lingo that I use. I call this our top fraction, our bottom fraction, top numerator, top denominator, bottom numerator, bottom denominator. Just that's kind of the vernacular that I use, so you are welcome to use it as well. And our bottom numerator is just x minus 1, and our bottom denominator is x minus 3 times the quantity of x plus 2. Now, of course, just like our division problems before, there are going to be some pretty serious variable restrictions, right? Neither of these denominators can be 0. So x cannot equal -2. X can also not equal +3. X cannot equal -2, but we already took care of that. Also, this fraction itself can't be 0, or else we'd be dividing this by 0. So x cannot equal 1 either. All right, and now it's just a fraction division problem. We're going to multiply by the reciprocal. So we've got x plus 1 times x minus 1 over 4 times the quantity of x plus 2. And we're going to multiply by now x minus 3 times x plus 2 over x minus 1. And now we just look for some simplification opportunities. So these guys will simplify away. These x plus 2s will simplify away. I think that we end up with a grand total of x plus 1 times x minus 3 all over 4. So that is the simplified version of this complex rational expression, of course, with these variable restrictions. So that's strategy number 1. My second strategy is slightly different. And I'm going to write this original fraction. We're going to do the same two problems again with a different strategy. I'm going to write this original fraction a little bit more vertically. I'm going to write this as 3/4 divided by 5/6. So now note, we've got a fraction here, and we've got fractions within fractions. And what we would really like is to eventually have a fraction which we have just one number and one number. We don't want a fraction within a fraction. So what can we do to 3/4? And what can we do to 5/6 so that they are no longer fractions but just nice integers? Well, if we multiply the kind of top fraction and bottom fraction by the least common multiple of 4 and 6, then we will no longer have a 4 in our fraction here. They will simplify away, and we will no longer have a 6 in our fraction here. They'll simplify away. Let me show you what I mean exactly. So the least common multiple of 4 and 6 is 12. So what we're going to do is we're going to multiply the top fraction by 12 and the bottom fraction by 12. Now, I kind of wrote these pretty awkwardly because visually this can be pretty tough. Remember that when we multiply 12 by this top fraction, we're multiplying it by just the numerator. It's kind of like we have 12 over 1. And it's kind of like we have a 12 over 1 here as well. I tend not to write these over 1 over 1s, but it's really important that visually you recognize that, yes, this is just 12 times 3. We're going to get a 36 over 4, which is going to reduce to 9, which is pretty fantastic. So in this new fraction that we end up with, we're going to have a 9 as our numerator, right? 36 over 4. In our denominator, we're going to have 60 over 6, which is 10. So our denominator in this fraction right here is going to be 10, right? It's going to be 12 times 5 and 1 times 6 and 1 times 4. So I just really want people to be very aware of how this actually works, because usually this is all I write. And of course we don't write it so awkwardly. It's probably going to look something like this. But kind of visually, I want people to know exactly what's happening when someone writes something like this. And note 9/10, let's hope that's the same thing we got earlier. Woohoo, 9/10, awesome. Okay, so that's the strategy there. Let's see how that applies in this rational expression. Again, first thing I think we want to do is factor everything. So it's the same factorization as before. I might do a little bit of copy pasting if you don't mind. Copy and paste. Okay, so now what we need to do is for each of these little denominators, so for this guy and this guy, we got to say, what is our least common denominator or our least common multiple in this case? I hope you can figure this out on your own, but I think our least common multiple is going to be 4 times x minus 3 times x plus 2. And so this is what we're going to multiply both our big numerator and our big denominator by. And in doing so, we will have no more fraction here. We will have no more fraction here. We're going to have a nice, simple rational expression on our hands. All right, so let's go ahead and do it. So we're going to multiply both the big numerator and the big denominator, if you will, by our least common multiple in this case, 4 times x minus 3 times x plus 2. And again, visually, you got to be really careful about how you write this because, of course, we're multiplying fractions here. So more or less, this is kind of like all of this over 1 and over 1. I'm not going to write that now, but if it helps you to do that, to keep track of things visually, you certainly may. And if you look in our big numerator now, we are going to have some simplification opportunities. Both the 4 and the x plus 2 are going to simplify to 1. And our resulting numerator is just going to be x plus 1 times x minus 1 times x minus 3. All right, so x plus 1 times x minus 1 times x minus 3. And look, our big numerator now is just a polynomial. There's no fraction within a fraction anymore. In our denominator here, we've got some more simplification opportunities. I think that the x minus 3 and the x plus 2 are going to simplify to 1, meaning that our resulting denominator is just going to be 4 times the quantity of x minus 1. And so what we've done is we've taken this complex rational expression with fractions within fractions, and now we just have a polynomial over a polynomial, and there are some more simplification opportunities. I think that these x minus 1s will simplify away, leaving us with our final result of x plus 1 times the quantity of x minus 3 all over 4. And hopefully this is the same simplified expression that we got the first time we did it, and indeed it is. Fantastic. So those are really the two methods that I use, and sometimes one is going to be easier than the other, and we're going to do a couple more examples right now to make sure we're really comfortable with them. All right, so let's make it happen. If you scroll with me to the next page, I do want to make a really important note that this multiply by the reciprocal method works only when our complex rational expression is of a specific form. And here's an example to illustrate this. So here we obviously have fractions within fractions. And it may be tempting to do this. We might say, all right, well, what we're going to do is we're going to take that numerator, x plus 4 over x minus 1, and we're going to multiply it by the reciprocal of our denominator. Now, what's the reciprocal of 1 over x plus 1 over 4? I will tell you, the reciprocal of this is not going to be x over 1 plus 4 over 1. That is not going to be the case here. That's an angry face. No, 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 no. So in order to find the reciprocal of this denominator, what we first need to do is actually write this denominator as just a single fraction. So what I'm going to do is I'm going to kind of do a little bit of shorthand. I'm going to zoom way in. I'm going to multiply this first fraction by 4 over 4 and the second fraction by x over x. So now we have that same denominator. So this, if we were to write this big denominator as one fraction, it would be, let's see, 4 plus x over 4x. And now that we have kind of a simple fraction as our denominator, I know this is super confusing, then we could go ahead and multiply by the reciprocal of this, because it's hard to find a reciprocal unless you're dealing with a single fraction. So we have the reciprocal is 4x over 4 plus x, which is also the same as x plus 4. And there, okay, we'd have some simplification opportunities. And our final simplified version would be just 4x over x minus 1. Right now I'm not taking the time to talk about the variable restrictions, but I'm sure you could find them. So I just want to make that note that in order to use this multiply by the reciprocal method, which I think is often much easier, we do have to have a specific form of our complex rational expression. If there's addition of fractions or subtraction of fractions within this big fraction, it's going to be a lot harder. Okay, let's get down to some examples. All right, so I'm going to guide you through 3 of them, and then I'll have you try 3 on your own. Of course, if you feel like you're ready to rock right now, be my guest and pause the video and give them a try. But here we go. So in this first example, I noticed that we have what I call a very clean complex fractions. One nice fraction over one nice fraction. I think I'm going to use the multiply by the reciprocal method. But first things first, let's factor everything. So I think we're going to have x plus 3 times x minus 3 over x plus 4 times x plus 1. All of that over x plus 3 times x plus 3 over x plus 1 times x minus 1. All right, let's take a moment to talk about our variable restrictions. I fix x cannot be negative 4, it cannot be negative 1 again, or 1. So x cannot equal negative 4, 1, negative 1, but it also can't be negative 3. All right, so we got that out of the way. Now, time to rewrite this as a multiplication problem, because, we could just write, instead of dividing by this fraction, we can multiply by the reciprocal. So we're going to have this same one again, but we're going to be multiplying it. Am I going to have space? Yes, I will. By the reciprocal of this guy right here. I know I'm doing a lot of shortcuts with the copy-paste thing, but bear with me. And there we go. So now we've got a nice multiplication problem. Are there any simplification opportunities? I see an x plus 3 and an x plus 3, an x plus 1 and an x plus 1. And you know what? I think that's about it. So I think our simplified version will be x minus 3 times the quantity of x minus 1 over x plus 4 times the quantity of x plus 3. And you know what? Sometimes we can simplify a whole lot. Sometimes we're left with quite a bit. That's totally fine. But this was one in which the multiply by the reciprocal method totally worked really well. In the second example, I noticed that we've got some subtraction of fractions going on in our big numerator. If we could rewrite this as just one fraction with a single numerator and a single denominator, then multiply by the reciprocal would make a lot of sense. Here, let's go with the least common multiple method. And I think the least common multiple of what I will call our mini denominators, so between 5x and 5x, I hope you agree with me that the least common multiple of those is 5x. So if we multiply this expression by 5x over 5x, hopefully we will be left with a fraction that has just a nice polynomial over a nice polynomial. Well, okay, note to self, one thing to remember here, I'm going to even put in a little set of parentheses. We got to remember that we're going to multiply this 5x by both of these individual terms here. And of course, this 5x, it's kind of like 5x over 1. Right? So it's really going to be applied to the numerators. So in our first fraction, we're going to get 5x over x, also known as just 5. And in our second fraction, we're going to get 5x over 5, also known as just x. So we're going to have 5 minus x as our numerator. And our denominator, well, this 5x and the 5x are going to simplify away. So we just get x squared minus 25. All right, and now let's look for some simplification opportunities. I think that denominator is going to factor as x plus 5 times the quantity of x minus 5. And the numerator, we can factor out a negative 1. Negative 1 times the quantity of x minus 5. And so I do see a simplification opportunity. These x minus 5s will simplify to 1. And we are left with a final expression, negative 1 over the quantity of x plus 5. Note to self, I did not take the time to talk about some variable restrictions. I think in this case, x cannot be 0. X cannot be 0 here, and also x cannot be 5 or negative 5, because if it were 5 or negative 5, this would be 0 as well. So x cannot equal 0, 5, or negative 5. I'll be honest, as we make our way on, I become less focused on these variable restrictions as I am with how do we simplify these. Okay, one more before I have you try some on your own. Ooh, we got some negative exponents here. So we're going to have to remember our negative exponents. I hope we remember that x to the negative third power is the same thing as 1 over x to the third. So we got 1 over x to the third minus x over 1 over x to the second minus 1. Again, your choice, because we've got a whole lot going on in both our big numerator and denominator, and it's kind of an awkward looking expression altogether. I'm going to use the least common multiple method because for me it's easier in this case. If you want, you could subtract these and write them as one fraction, and subtract these and write them as one fraction, and if you can, that's great. And then you could do the multiply by the reciprocal method. So I think our least common multiple of all our mini denominators, so x to the third here, over 1, x to the second and over 1, I think our least common multiple is x to the third. So let's multiply by x to the third over x to the third, and do remember that we're going to have to distribute this, right? This x to the third is going to be applied to both terms, as is this x to the third. I'm going to write it like this, just for consistency's sake. So let's see what we're going to end up with. Well, x to the third times 1 over x to the third Those x to the thirds are going to simplify. We're just going to get 1. X to the third times x is x to the fourth. And in our denominator, x to the third over x squared is x. X to the third times negative 1 is negative x to the third. And so now we are ready to look for some simplifying opportunities. 1 minus x to the fourth factors as 1 minus x squared times 1 plus x squared. And in our denominator, I think we could factor out a common factor of x times the quantity of 1 minus x squared. Boom, we have some simplification to be done. And I think our final result will be just 1 plus x squared all over x. Variable restrictions, let's take a look-see. I think x cannot be 0. Because if it were 0, we'd have 0 in the denominator. I think x can't equal 1 or negative 1 either. Because if our x were 1 or negative 1, this fraction would be 1. 1 minus 1 would be 0. You can also see that from this expression right here. And so those are our variable restrictions. Like I said, I am not so interested in these right now as I am with your ability to simplify these expressions. So that was 3 that I just walked you through. And so if you're now feeling able to do some on your own, well, I certainly hope so, why don't you take a moment to pause the video and try these next 3 on your own, and then play the video, and we'll see how it went.